Ever been on a job before sunrise, generators running, diesel in the air, and concrete trucks starting to stack up? And you're thinking, do we order the right mud? Is this mix going to hold up? Did I ask all the right questions in the pre-pour meeting? And if this thing goes sideways, am I going to know what to do? That's why we built Concrete Logic Academy. It's for concrete people who want to get better at the work, not theory, not recycled conference slides, stuff you can actually use on the job. Go to concreteschool.co and get free access while it's open. Again, that's concreteschool.co.
What's the most used man-made material on Earth? I'll give you the answer. Concrete. This is the Concrete Logic Podcast. Have you ever stopped to think about the sidewalks, driveways, bridges, or the buildings around you? They're all made from concrete. So why don't we discuss it more? In each episode of Concrete Logic, we'll explore a unique concrete-related topic with the help of industry professionals shaping the trade's future. We'll talk with suppliers, contractors, architects, engineers, specialists, and even proponents of competing materials. We'll get their views on concrete and their visions for its future. So get ready to mix things up with Concrete Logic, where we turn the spotlight on the material that's everywhere but often overlooked. This is the Concrete Logic Podcast. And now, here's your host, Seth Tandit.
And welcome to another episode of the Concrete Logic Podcast. In the last episode, we had Jason Adams on, and he challenged one of the concrete industry's biggest assumptions that exterior concrete does not need air entrainment on exterior concrete. So today we're going to take this conversation a little bit further with a new guest. My guest today is, I'll call him Baker's resident concrete materials expert, Dr. Bruno Fong Martinez. Bruno earned his PhD from the University of Texas at Austin with a focus on concrete durability. Before joining Baker, he worked as a concrete engineer at Kiewit, and today he helps Baker develop and review specifications, optimize concrete mixes, troubleshoot field problems, and evaluate durability and surface life. He is also active on ACI and ASTM technical committees, which means he gets to see both of what the standards say and what actually happens when the concrete shows up on the job site. Bruno believes unnecessary air entrainment may be one of the biggest preventable causes of concrete problems and waste. So today we are asking, are we putting air in too much concrete? So Bruno's going to help us with that today. But before we get started, like I always do, I'm going to share with you how you can support the podcast. And the first thing is, if you enjoyed the show, please share it with a colleague or a coworker. The next thing you can do is, if you go to the website for the podcast, too much coffee today, Bruno. If you go to www.concretelogicpodcast.com, there's a couple ways you can get a hold of me. The first way is at the top of the navigation bar there's a option that says Ask Seth. If you click on that, email form pops up. And what I'm looking for are topic or guest suggestions. So please reach out. Let me know what you want to hear, what you want to learn about, who you want to hear from, because that's what the show is all about. The second way you can get a hold of me is in the bottom right-hand side, there's a microphone. You click on that, and that's like leaving me a voicemail, same thing, topic or guest suggestions. The next way you can support the show is to donate to the show, and how you do that is on the same homepage. On the upper right-hand corner, there's a blue button that says support. If you click on that, it'll pop up a PayPal page, and you can donate any amount. There's not a fixed amount. So what I'm looking for is, if you get any value from the show, you send some value back, and any amount is greatly appreciated. It helps pay for all the stuff that goes on here, software, hardware, things of that nature that you need to run a podcast. And today I want to thank Zach Richardson for his donation. He's donated to the show. So I appreciate that, Zach. And then the next way is, if you want to learn more about these topics in more of an academic way, and possibly if you need professional development hours or CEUs, if you need any of those as a professional engineer, you need to check out concretelogicacademy.com. Check that out. That's another way to get your PDHs and your CEUs if you need them. Or if you just want to learn, if you're a concrete contractor, you want to learn more about concrete, concrete suppliers as well. That's a good way to continue learning about concrete on your own. So with that, Bruno, let's get to the topic at hand. Are we putting air in too much concrete? That's what we're going to talk about today. So do you want to get us started on that topic? It seems to be something you're passionate about.
Sure thing. Thanks, Seth, and thanks for having me again. Listened to your episodes before, so I've gotten some good insight out of them. And yeah, this is a sort of a passion project for me, this specific topic, because it's such a simple one that I just kicking myself in the head of why we can't get this right as an industry. Because if you talk about, improving the industry any sort of way, either performance or sustainability or anything, like this is such a low hanging fruit of like, if we can as an industry agree on air entrainment, we can improve concrete across the board, reduce cement content, reduce rejected trucks, improve thermal performance, improve other properties. And we can't seem to get it right. In my relatively short career, I've had many, many fights with some very big clients that have made me put air in some concrete that most definitely did not need it. And that led to a bunch of issues. And again, there's unfortunately a bit of a misunderstanding on the technical side, and then also misunderstanding at the constructability project side of what it actually does to your concrete. So yeah, I have lots to say about it.
Well, good. Let's I don't think I did a particular good job in the episode with Jason. I think if we could, so let's start with this. You're not saying remove air entrainment totally out of the picture, right? You're saying there's applications for it, and there's applications that it's not good for. Is that correct?
Correct. And I've broadly dividing it into what I'm going to call the red light, green light, red light, yellow light, green light. So for example, red light, all of Canada. I mean, no question, you're going to need air entrainment. It's very severe freeze-thaw environment. For sure. You're going to need it. And if you're a concrete producer in those regions, you're used to it. You know how to produce it. Yellow light. Let's talk about some of the states that maybe have part of the northern part of the state maybe has freezing cycles, but the southern part of the state does not. Texas would be a good example. Northern Texas can get cold. Southern Texas does not. Green light, Hawaii. The lowest recorded temperature in Hawaii is 60 degrees. So you want to talk about free, and there are thousands of cubic yards of concrete with air entrainment in Hawaii. That's for a fact.
All right. Let's go back to the basics. I think you'd be good to explain this. Let's explain first air entrainment versus entrapped air. And then also, can we talk about the mechanics of air entrainment? Like what is it? What are we trying to achieve in the concrete, and why is it, how it protects the concrete from freeze thaw? If you could go over that, and then we can start picking apart the things that you don't like about it.
Sure. And I'll be generic because I didn't particularly prepare on the mechanisms itself, because freeze thaw protection is actually very complicated. So I'll keep it pretty basic. In general, just the process of mixing concrete, whether it's a lav mixture or a truck, and traps air. Just because you're blending materials, you're just trapping air. That blending process inherently traps air, and we call that entrapped. And typically we give that a number of 0 to 3% by volume. So any concrete out there that you mix it in a ready mix truck is probably going to have 2%. 2% is a good middle value. Those voids, again, just happen from the mixing action. Most of the voids got collapsed during the mixing, but some remain. But they tend to be what I'm just going to say, like on a little bit of a larger side of bubbles, not enough to help you with freezing and thawing. If you put an air entrainer chemical in your concrete, this air entrainer, you can think of it sort of a little soap protector thing. So it protects your air bubbles as you're mixing, they're not collapsing. So it doesn't necessarily create the bubbles, it just protects them, coats them, so it prevents them from collapsing. So when you're mixing, when you have your mixing action, those bubbles remain, and they tend to be of a better distribution, smaller size, better distribution, so they're distributed throughout the whole concrete matrix. And that percentage tends to be maybe 5 or 6%, which again, you would not get from entrapped. Entrapped, if you mix it properly, you're going to be in the 2 to 3 range. With the chemical, maybe you can get to a 6, 7, and so on. So that's basically, I'll pause there if there's any comments from your end?
Yeah, that's perfect. So when you do air entrainment, it protects the bubbles, and it kind of spreads the bubbles throughout the concrete, so you don't have like entrapped air. Wouldn't it be like, you're supposed to get it out when you vibrate the concrete, right? That's why we're vibrating the concrete to consolidate, get the air out of it. So when you have air entrainment and you're actually putting an admixture additive into the concrete to create that, the bubbles are supposed to go throughout the concrete evenly if it's done right. Is that?
Yeah, more
Yeah.
or less. And again, the size of the bubbles is also different. I don't have it in front of me to tell you like the micron difference, but it's easy to tell when it's entrapped versus entrained because the entrained ones are much smaller. So, the same amount of volume, like let's say one big bubble has a volume, but that volume can also be represented by, let's say, 100 smaller bubbles dispersed. And it's better to have those 100 smaller bubbles all throughout than just one big bubble in the middle.
Because I guess what I was getting at is where the freeze-thaw action of concrete is when water gets in there and it freezes, it expands, and then the tiny bubbles kind of protect the concrete from giving it room to expand. Is that how that mechanism works? Is that why we air and train it?
Yes, that's the easier mechanism to explain. There's actually so there's no consensus really as to what mechanism exactly is taking place.
Okay.
You can read the literature, and there's some complicated ones that I won't even try to mention because I'm gonna mess them up. But the simplest one is based on that. It's there's water saturated in the concrete. There's a freezing event. The water inside of the concrete pores wants to expand as it's basically transforming into ice. Ice takes up a larger volume than water, so then that extra volume needs somewhere to go. So the air voids basically provide release from that expansion.
Okay.
So that's one of the mechanisms. It's not the only one. There's a couple other ones. But in effect, again, we as an industry have agreed that if you put air entrainment in your concrete, you're good. We kind of see it as a very binary issue. You toss air entrainment and you're good. One of my specialties is durability and service life, like you mentioned. And right now, we actually don't know what we mean by saying you're good. Like we, as an industry, we don't know if that really means you're good for 100 years, because that's what some of the projects are looking for. But right now, the state of the industry is like, yes, put in air entrainment and you're good. And we kind of assume that it's good for 100 years, but we really don't know.
I got you. Yeah, that was perfect. That's what I was looking for, is an explanation of why, my understanding is we put air entrainment in for exterior concrete because it's exposed to the freeze-thaw, temperatures out there. And that's what we're mainly trying to protect the concrete for. I'm not familiar with the other ones. It sounds like I need to do some reading.
I can send it to you. But
Okay.
That's from my grad school days.
Okay.
And it's a bit shocking to me that even, we're as advanced as we are, there's no specific consensus. And part of it is that we just somebody figured out air entrainment works and we just call it good. But there's a lot more need for research. A big part of the damage happens from it's a cyclical nature. So just like the name says, freeze-thaw, you need both the freezing and the thawing. And I don't think that's very well understood. So I'll just highlight it. Myself, I live in Denver, Colorado, and Denver, Colorado has rampant freeze-thaw damage because Denver gets cold, it snows, but it also gets very sunny. So there's actually a lot more freeze-thaw cycles in Denver than in super cold places like Alaska. Alaska freezes and it stays frozen. And guess what? The damage happens when it's cyclically freezing and thawing because you have that water going into the pores, freezing, and then thawing and freezing and thawing and freezing.
Yeah. Huh. Well, I think you kind of hit on something that I believe you take issue with, is the testing for air. So I think that's one of the items that you had that you wanted to talk about. Is that right?
Yeah. So specifically when talking about regions of the country where you most definitely do not have freezing and thawing concerns. I'll keep using Hawaii as an example. The moment that you ask for air entrainment in your concrete, you're exponentially complicating things for everybody across the board. First of all, now the concrete producer needs the chemical. So that means that they need now a new tank with the chemical, and they need to pipe into the plant or whatever. That's an expense. That's a complication. Now you put your chemical on your concrete. Hopefully they get the dosage right, but who knows? Now that concrete needs to be tested for an air content, and that's going to be another acceptance criteria. So all of a sudden, your specification says you have to hit the right slump, maybe the right unit weight, but now also you need your air. And air is very complicated. Air changes with time actively in a truck. The more mixing action, you can actually continue to destroy the air bubbles. Also, as a concrete sets, it can also, make a difference. So now that you have air entrainment, you have another criteria for testing to pass. It's also another test that somebody physically has to do, and it takes time. If anyone's ever run an air test, it's not a super fun thing to do. And my main issue is that it leads to a lot of waste. Again, I'm specifically talking about Hawaii right now, because all of a sudden you can reject a truck if it doesn't have the right air because it's not within spec. It never needed the air, and now you're rejecting trucks left and right. That's wasted material, wasted concrete that now is just going to go somewhere else and is not in your job. And, that's thousands of pounds of cement, regardless of what type of cement it is, or regardless of how green the cement or the SEM is. It's all waste, and it happens all the time.
Yeah. So when you say other complications, you covered on the supplier side. What about on the contractor side?
On the contractor side, a big issue with it is strength. So, inherently, you can just picture if you have something full of air voids, it's not going to be as strong as if it was just solid, a solid chunk. Versus now you have, let's say, 6 or 7%. So typically the rule of thumb is that every percent of air drops your compressive strength by about 5%. So that complicates everything down the road. Let's say this is a mass concrete element, and now you're being asked to put air entrainment in it. Now you're going to need to put more cement in it to make up for the loss in strength. But because you're mass concrete, you really don't want the cement because you're trying to be on the cooler side, and more cement is going to mean a higher temperature. So it's kind of backfiring there. You might need more fly ash to counteract that effect. Now you have more fly ash. Now maybe that's pushing your strengths to later on, beyond 28 days, maybe to 56 days. You also have the potential for the admixtures to have an incompatibility. I typically don't like to put too many chemicals in my concrete. I say if you have more chemicals than fingers in your hand, that's an issue. But sometimes they don't get along, even when they're the same brand. So that's on the contractor side of low strengths, thermal issues, complications with the mix, complications with the chemicals.
About on the pumping concrete and placing and finishing.
Yeah, good point. So like I said, air content is actively changing in fresh concrete. So the time that it leaves the plant, it could change by the time you get to the site, and then it could change again by the time it gets pumped. Typically, it's a rule of thumb that you lose maybe 1% across a pump. It can really vary based on the configuration, the length of the pump, but typically you're expecting it to drop, which means that you're going to ask the plant to just hike up the air way high to account for the transport time, to account for the pumping, because sometimes the job will ask you to do acceptance out of the pump. So again, you're just asking for so much complication when you didn't need it right off the bat. So all of that, unnecessary problems, unnecessary rejected trucks, unnecessarily low brakes, more cement is happening actively.
So where would you say air entrainment is necessary? Because you're not advocating or removing it at all. So where is it necessary? You said Canada. You said it sounds like most of the United States, and then southern part of the United States. You're saying doesn't need it.
Correct. And I'll go back to again the red light, green light, yellow light analogy. I think one of the key research items that is missing is how to address the yellow zone. So I recently had a call with Professor Anton Schindler from Auburn University, and he's part of a research project with the Alabama DOT, where they're trying to figure out for their state, again, how do you map the state? How do you create a map at a state level that takes into account freezing cycles, not only freezing cycles, but also saturation cycles. So it's both precipitation and freezing. And that's how you're able to tell, okay, where's my high risk zones? Where's my low risk zones? Where can I remove air entrainment? Where do I need to go to the severe zone? Where do I need to go to the moderate air? And just broadly, if you're severe, you just need more air content. If you're moderate, you need less. If you're in the negligible zone, then you're good with entrapped air. So right now, I would say like that's part of the issue is that somebody discovered that air entrainment was good, and we just took it as a blanket statement and said, put air in it. Who cares how much? Who cares how much is appropriate? We know that it works, so just go with it. And we are kind of overshooting it, in my opinion, because that level of dialing down in a geographical zone, mapping the freezing cycles, the precipitation cycles, that has not happened. That work. And again, I'm collaborating with this professor, or discussing with this professor at Auburn on how they're doing it for Alabama specifically, and maybe this is the beginning of a larger initiative for more states to adopt. So that's kind of where it's at.
Okay. So it sounds like we got some work to do to figure out what that is. Is I think we cover definitely where it's necessary. So how do we approach this from job to job? Are you making any changes now with our Baker projects? Looking at this?
So I'll say that I understand the root cause of this issue. Again, is the construction industry is, very restrictive by design for a reason. We want safe structures. Nobody wants any collapses. And so it's very understandable that we've gone in this direction. But again, I think we've overcorrected. And also another part of the issue is that the way that designs are being done nowadays, you have giant design conglomerates that have offices all over the country, all over the world. And you have people from northern climates that are used to northern climates designing in Hawaii, West Texas, and without understanding what that is. And they're used to putting air entrainment in their specs. They don't have any issue with that. So they just copy paste the spec from Canada into West Texas, from Michigan into Hawaii, whatever. All of that happens all the time. And I understand where it comes from. You also have a severe lack of just education within the structural engineering community about concrete materials. I myself am a materials engineer. It would be a crime to call me a structural engineer. Unfortunately, I don't think structural engineers, have that level of awareness that they don't know concrete. They know the structural side, they know the numbers, but they don't know the concrete side. They just think concrete's this menu that you check boxes, and they say, give me the air, give me the strength, give me the durability, bang, 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 bang. And I think they're asking for too much, and there's a limit to what the materials can do. So that's kind of where the issue is coming from. How I engage with it, I engage with a Baker project. Ideally, I get the specs early on, and I see that there is air entrainment. There's a current project in Louisiana that this is going on, and this is the best case scenario because this was brought to my attention. I submitted an RFI requesting removal of the air, and the client accepted. And that very small step probably has saved innumerable pounds of cement and rejected trucks and whatever things. And it goes to show that people are throwing things into the specs without really knowing what they're asking for. They're just copy pasting designs from somewhere else, from somebody else. And very few people are taking the initiative in getting project specific specs for the specific environment. But yeah, that's again, the best case scenario is we RFI it. Client agrees, we see an optimization, let's do it. There's been other cases where the client does not agree and they stick to their guns, and we build in air entrainment to the estimate and it gets placed. That also happens.
Yeah. At least too, it gets documented that, we questioned the specification on having the air entrainment in there. So if there is an issue with the concrete down the line, we could be like, oh, we did ask you about this.
We did. Part of the broader issue is not all parties have a dedicated concrete subject matter expert like myself. And so if I'm trying to initiate this discussion with the client or with an engineer of record, if they don't know about air entrainment, they're gonna step back and just rely on what they've done. They don't know me. Maybe they don't know Baker. They have no reason to believe me. They don't want to, go through the hassle of learning the mechanisms. And so they just rely on what they've done before. And it's easy to say reject. No, follow the spec, do as told.
Yeah.
So there's a little bit of, I think everybody can learn a little bit.
Well, now you can point to this podcast episode. You can send it to them, say, listen to this. It's only about 20, 25 minutes long, and I'll explain to you what I'm trying to get at. And there you go. Then
I will say, because this has become such a passion project for me, I have reached out to industry folks, because again, if it's just coming from me, honestly, people, I mean, there's not good reason to listen to me. But I have reached out to industry folks, specifically at ACI, to see if we can take a stronger stance against this, because everyone in the technical academic circles, I mean, I think they agree with me, but the industry documents they're not as black and white and say, don't use air in Hawaii, but I think they should be. So one of the initiatives that I'm pursuing, in addition with talking with Professor Schindler at Auburn, is can we come out with an ACI stamped document, something like a tech note, which is a very brief memo, a note, which just says, for this issue, we as an industry, this is ACI, the Durability Committee, this is what we recommend. So I'm hoping, again, once that gets going, if that document does come to light, then I can say it's not just my word, it's the group of ACI experts. We got together, we wrote this very short document saying, this is when you use air, this is when you don't use air. Please follow it. This is an industry consensus. It's not just, my own dream.
Not Bruno's dream. ACI agrees with me. All right. Well, that's great. I think that's a good spot to end the day, Bruno. If folks want to reach out to you, especially, I think we're around 13,000 coworkers out there. They're listening to this. What's the best way to reach out to you?
Yes. So I'm, again, happy to engage with the Baker projects, help them out with any concrete issues. Not only specifically air, but anything. If you wish there was anything better with your concrete, I can help with that. I'm on the Baker directory. Email is fongmartinezb@Baker Construction. But yeah, my contact info is out there on Teams and on Outlook for Baker guys and gals.
And if there's any engineers or architects out there that want to learn more about that, well, I'll put a link to Bruno, his profile on the website, on our show notes. I'm sorry, that will lead you to the website so you guys can get a hold of him. And sounds like we can help you eliminate some cement if that's a goal for you. So, Bruno, I appreciate you coming on the show today. It was fun. I hope you come back and we can question more things that we can help concrete out with.
Sure thing. Thank you, Seth. Appreciate it.
Yep. And folks, until next time, let's keep it concrete.